Hello everybody. In previous example, in our previous video, we discussed about queue data structure, and we got to know that queue is like a simple line or queue of variables, and this queue of variable is based on first in first out principle, right? The first one to the queue will be served first, and the last one in the queue will be served at the last, right? So based on this queue data structure, we got to know that there is a head element and there is a tail element. Head element will be the one who will be the first to be dequeued, and at the rear element, whoever new person will be in the queue will be added or enqueued to the queue, right? So in this video, what we will do is we will build this method implementation. Essentially, there are two methods to be implemented. There is an enqueue method and there is a dequeue method, right? In enqueue method, we saw that when a new element, let's say element number 5 is to be enqueued, what will happen is it will be added to the tail of the queue, and then it will set as the updated tail value, right? And in the dequeue method, we saw when a dequeue operation is performed, the head of the queue is removed and the next element or the next pointed node will be set as the new head, right? Essentially, queue uses node value or a node class, right? And the node class looks something like this. Let's go ahead and start with the coding part. Create a class called queue dot queue, right? First, what we will need is we will need to build this node, right? This value. So essentially, node structure in queue is similar to the one that is used in linked list and the one that is used in stacks. So I'll build a new class called class node, and essentially this node class will have two elements. One will be, in this case, we'll take an integer type. It will be named as value, and there will be a node type, same self, point to next. This next node will be a pointer referring to the next subsequent node, right? Now let's build this constructor. The constructor will be quite simple. We will accept an integer value, right, and set this integer value to the new node, right? Now this essentially will be the node structure that we require, and now a queue class will implement have two members or the two elements or the two fields. First will be called private node first, right? It would be equals to the head, and private dot last. Then it will have a variable will be integer of length. This will hold the length of this queue, right? Now first step we will build the constructor of this queue, right? We need to create the instance of this queue class. So what we will do is first we will create a public queue, and the queue will accept an int of value, and this will basically first create the new node, create a new, assign this to this dot first equals to new node, this dot last equals to new node, and this dot length is equals to 1, right? Because we are already adding a new node. So essentially this new node will be pointing to both first and last node. So basically the first node will be pointing to new node and the last node will be pointing to this new node that we just created using the input value, integer value of value, right? So our constructor is ready for queue class. In the next step, what are we going to do is we try to implement the queue class, the enqueue method, right? So we'll add the enqueue method, following then we'll add the dequeue method. Before we go ahead with both those methods implementation, let me test out this particular method called queue. So for that I'll call a class demo and create a main method, and then we'll create our own queue with queue, a name as queue, let's say my queue, right? It's much better to understand. And then we'll say my queue print. So we're gonna print out sysout dot print my queue dot, acha, those are private variables, so it won't be visible for now, so I'll change it to public. change it to public, change it to public, right? We don't need to have getters and setters method for now. For simplicity, simply say first dot value, then css print last node value. So let's print out first node value like this, right? Say last node value, last node value, correct. And also have to print out the length, so length would be my q dot length. Now there is this issue called node is to be renamed. More action. Let's run this. I hope there is no error. So it's basically giving an error that this particular node is duplicate. It's duplicate because in the stack also we implemented the same node and class, right? That's why. So what I can do is better rename it to Q node. So let me rename it to Q node, right? So say Q node, rename it to Q nodes everywhere. Whatever we have defined Q node, we'll have to rename it to Q node, and then we'll also have to use Q node for creation of new node. That's fine, and we'll say Q demo. Right, the issue is because of duplicate value. We in the stack demo also we created the same node and stack value. Now let's rerun this once again, right? So the constructor part will run and build our new initialized a queue with the first value as 5, last value as 5, and length as 1. Okay, so up till now we have managed to create the constructor method for the queue class, and now we will start with creating enqueue method. So let's go ahead and prepare the enqueue method. Remember, enqueue is a process of adding a new element to the queue, right? So in order to add a new element for the queue, firstly we'll have to create the new node. Let's define the method signature first. Enqueue, it will accept an int of value, and the step one would be to create a new node. So this line would create the new node, and before we add this new node, because we are enqueuing this new node, right? So as per this diagram, let's replay this diagram. So as per this diagram, what are we supposed to do is, let's say we have a already node queue with one node as the head and four node as the tail. So what are the purpose of this enqueue is that whenever, let's say we are adding a new node of, let's say 5, so what we have to do is we need to update the last element of this node which is pointing to null to point it to the new node like this, right? And shift the tail pointer from 4 to the new tail which will be 5, right? So we'll do this same in the code. What is supposed to do is, firstly we have prepared a new node, right? What we need to do is firstly to check if the node is empty. So if the length of this node is 0, then we set the first element to the node and last element to the new node, right? Because the queue is empty, right? Else in the next case, uh, this dot last dot next should be the new node, right? Should be pointing to a new node, and this dot last should be a new node, right? So the enqueue method is returning some issue. First of all, the last is the new node, queue node. So let's read the message. What it says is, acha, change the field next type to queue node, right? So in the queue definition, we should update this to queue node, right? So we forgot to do that earlier. With this, now this error will go, and at the exit stage, we'll update the length because we are adding the new element. We'll update the length, and we'll have to define the return type. So the return type of this will be void, right? So this is a simple enqueue method. Step one, we create the new node. check if the queue is empty or not. If the queue is empty, we'll update both the first and the last node with the new node, and in the else condition, we'll update the last node next to the new node and update the last node to the new node, and finally increment the node. Now let's go ahead and create the dequeue method. The dequeue method will return a node, so it will be queue node dequeue. And before we go ahead and build this new node, let's look at the diagrammatical representation. So when there is a queue starting from 1 2 3 4, 1 is the head and 4 is the tail, right? So when we dequeue it, the first element or the first person in the queue in the line should be removed from the line, right? So the node number 1 will be removed from the line, and the node that was pointing to the next of that first node, which is point number 2, should be updated to as a new head, right? So same thing, we'll try that in our code. What we will do is, firstly we will check if the length is 0. If the length is 0, we will return null because there is nothing to return. And in the else part we will mark the first as the current node and the first equals to the next node, right? And mark the current dot next is equals to null, so the current node, which is the first node, is break from the next pointer, and finally decrement the length by 1. Now let's test this in the same way. I should return, right? So we'll return current node, current return current node. Now we'll test both this enqueue and dequeue method. So what we'll do, first step is we will myQueue enqueue a new element. So we'll enqueue, let's say after 5 we'll enqueue 1, and then mymq 1, and then when we do check the last node, in this case the next last node should be 2, right? Let's run this and test this out. Right, so the last node is updated to a new value of 2 because the last one enqueued was a node value of 2. Now let's test the dequeue method. My queue dot dequeue, right, and it will return a queue value is print dequeued element will be value, right? So in this case the first element, which is the first node value of 5, will be dequeued, right? So that's it. These are the simple dequeue and mq method for this particular data structure. If you have any doubt, please let us know. Thanks for watching and have a nice day.